Welcome, my fellow dudes and dudettes. I hope you're having fun in this Chon class. If you're watching this, you're probably wondering what it is. Well, it's a video from my group featuring Jillian McCarty, Noemi Fernandez, and Isabel Martha. Pretty cool chicks. But they will talk about the chemistry behind lemonade and cookies. Two things. This will benefit you by learning about Charles' law, solvents, and solvents. If you don't remember those things, we'll remind you again. I hope you have fun and have a blast. Hope to see you again. Until next time.
The cookies will begin from room temperature and then placed in the oven at 325 degrees. The heat from the exothermic oven will be transferred onto the cookies, allowing them to bake because of the increase in temperature. Heat is partially made of kinetic and potential energy. Because the heat causes the atoms inside to wiggle around more, the space for wiggling is changing, which causes both kinetic and potential energy. Therefore, that is why in baking, the heat will cause the particles to move faster, making them collide with greater force and expanding at the same time. This expansion increases the volume. This clearly shows that if the temperature increases, so will the volume. This then shows that if the temperature increases, the volume will too, which represents Charles' law, or V1 over T1 equals V2 over T2. This means they are directly related. The oven that is being used is releasing heat onto the raw cookie dough, which is endothermic. The cookie dough receives the heat from the oven, exothermic, so now the cookies have a greater surface area once it receives the heat from the oven.
So lemonade do you want to make?
I want to make a regular lemonade, just lemons.
I think we should make a watermelon and strawberry lemonade.
But why? It's so much better. Like, come on, it's too acidic. You don't want that too much
Yeah.
acid in your body.
But acids are not that bad.
Oh, well, I think you're wrong.
Well, I think you're basic.
Oh.
I just dropped the base.
Water is a 7 on the pH scale, which makes it a neutral. Our lemons are a 2 on the pH scale, which make it acidic. Our strawberries are a 3 on the pH scale, which also make it acidic. Our watermelon is a 5, which is still acidic. And our sugar is a 7 on the pH scale, which makes it neutral.
So to make our solution, the watermelon strawberry lemonade, we're going to be using 1 cup of water, which is the solvent,
And half a cup of lemon juice, which is our solute, along with other 2 solutes, which are strawberries, 2 cups, and 8 cups of watermelon.
And we will mix them together and get our solution. So we're going to be adding the solute to the solvent.
And then adding 1 cup.
1 cup.
Adding our second cup. Oh, that's a lot. Okay. And
So it needs ice.
make it more tasty and refreshing. Couple more?
No.
Why?
Now we have our lemonade.
Cheers.
Very good. Wow.
That's what's up.
Thanks. I just dropped the vase. Oh. Get into my head. Get on my level. No, seriously, get on my level. I am not that short. Should I pause it? Yeah. I mean, 1 cup. Okay, Mom. Is that right? Oh, it's not right. I don't think. Can I focus? Can you see me? Oh my gosh. What's the temperature? It's too loud. I can't be funny. I'm not a funny person. No, I'm sorry. I'm like bloody. Peace out. What? Yeah.
Thank you for watching Crash Course Chemistry. I'm John Green. This is Hank Green. Join us next week when we'll be talking about Boyle's Law.
And our show is produced and edited by Jillian McCarty. Our script supervisor is Jenifer Solares. And the show is forced upon us by Miss Chon.
And as they say in our hometown, don't forget to be awesome.
And we'll see you next week.